In a paper that you had shared with me about PyLabRobot, I think one of the recurring themes that I saw, which got me excited, was around essentially scientists being able to share protocols across different types of labs with diverse different types of equipment, and being able to execute those protocols kind of more effectively. I think there was a link there to reproducibility, which I know is a large issue in science, where you have these amazing experiments that might be published in very prestigious journals, but then when other scientists try to recreate them, they aren't able to get some of those results. Maybe speaking back to your high school biology class that you described there. So could you maybe share more about sort of what that vision might look like and how it links to reproducibility?
Yeah, so definitely reproducibility, as I described earlier, was one of the key inspirations for me to even start thinking about Python for sort of describing biological protocols in the first place. So it's really a great inspiration. I think it's a little bit sad if you look at the state of biology today, where really the state-of-the-art way to communicate, if I have done an experiment to you, is me just telling you in English. There's like this whole tech transfer idea where we go together to the lab for like many days, and I show you specifically like how every finicky detail works, which is not really like a productive way of working together, in my opinion. If you look at computer programmers, if I had to collaborate with someone and I had to tell them write the code in this specific way, and maybe add a comment there and change this if statement into some other if statement, or change the while loop into a for loop, that's going to be very difficult to collaborate. Ideally, I'm just able to share some code that they can run, and everything just kind of works. And so how do we get sort of more towards this? The computers are like sort of the ideal scenario where you can just share code. So how do we get towards that for biology? I think one way is just to have a good representation of your protocols, where English it's very imprecise, and code is going to be very specific. So how do we get from one to the other? I think automation is kind of the answer there, where you can have code execute some experiments. And then together with that is, obviously people are going to have different devices from different manufacturers, which is great because they have all the different strength, and there's the competition, so it makes things better. And so it's important for this library that it is universal. So for example, if someone has a heater shaker or an incubator from one company, and someone else has the incubator and a heater shaker from a different company, if you share the code, it should still work. And so with PyLabRobot, we try to have like this universal language where for the bunch of machines to actually do the same thing, an incubator just stores plates at a specific temperature. So it only makes sense to have the same interface for all these different machines. So ideally in the future, people can just share a protocol and have a run on their setup no matter which machines they're using. And sort of the ideal vision that maybe is more of a dream, but I hope in the future that when people publish our paper online, that there's going to be a PyLabRobot script next to it of here's how to execute my experiment, and another scientist seeing this and downloading the code and forking it. Where forking is this concept of computer science where you take someone's code and you adapt it and make a change, and then either contribute it back or continue developing it on your own. And I think that is going to be a huge boost for collaboration and reproducibility.
Wow. Really digitizing the scientific method and the scientific process, and allowing people to, as you mentioned, share it much more easily than having to physically show up and look over your shoulder for a couple of days.
Definitely.
Yeah.